Namrata, invite all your friends to join fast.
Okay, sir.
Out of 18, 12 is present, 6 is absent. If I start, then it will again they are again will attack and better tell them to join on time.
Good morning.
Yes.
Okay, so so today we are not going for test. So be happy, and test is postponed for
Today we discuss about the
next Monday. Is it fine? Are you happy with that?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, test is going to be on next Monday. So today we are not going for test. And now we have to move to the module number 2 and continue where we stopped in our previous class. Okay, so now number is 15. So just wait for one more minute, then we'll start.
So molecular orbital theory. Earlier we had finished Valence one theory. I know it is all clear all of you. I have question answer also last time. So molecular orbital model orbitals on individual atoms connect to produce new orbitals is from molecular orbitals, which are no identified with our model.
Okay, so number is not rising. So we are starting.
Earlier, we told in the valence bond theory, the valence electron and valence.
Okay, is slides visible to you?
Valence electron.
Is slide visible to you?
Yes, sir. Yes, sir.
Okay, so in our previous class, we were talking about the vectors. So in that vector, we are talking about the different what are property of vector. So it can behave as a vector. So in that, we talked about that among the property that it should replicate, it should be of multiple copy. Its size was also an important factor, and that we can manipulate it also, so that its size, etc. And those things which are satisfying these criteria, we can consider under the they can serve you as a vector. So for that example, who are having these property among them, that is going to be one is a plasmid that can serve you as a property having such type of properties. Second is bacteriophages. So bacteriophages are going to be viruses. Simply you can say not just the bacteriophages also, or you can say viruses also can serve you as a vector. And next is the chromosomes also can help you. So chromosomes, they have this property, so you can load them a large amount. So that's why there are the few general property every vector should have. Now coming to the first one, as I mentioned, that the plasmids are the one which can you serve as a vector. So what are the what these plasmids are going to be, and why they are going to serve as vector? So first thing, as all of you know, that they are circular. Just a moment. Hello.
Important, please note down. It is very important. It's a basic concept. You understand this concept. So, orbital nothing. You know the physics you have seen already, the wave function. Sine wave, cos wave, this type of waves, this type of waves, and the wave. And increase the intensity, and some way our level decreases. Like positive, negative, it will ultimately zero. Negative, it will downwards. We have seen in the sine wave also. Here also, that was the concept.
Okay. So what the plasmids are? So plasmids are circular molecules of DNA. So that's a characteristic I think you all might be available about. And that when it's a circular molecule, that the important thing with it have independent existence, means it have its own everything, is it's not governed by the your bacterial genome, where we're talking what we are referring is that your nuclear genome. However, there is no nucleus in case of the bacteria, but still we can call it as a nucleoid or a genetic matter wherever it is located. And you just a normal term we are calling it as a nuclear. So nuclear genome, it's have independent to that, that is present in your bacterial cell. And it not just as in circular DNA molecule, and as it is having DNA simply means it is going to carry the genes, because the main role of the DNA is to carry the information, and this information is present in the form of genes. So this is the things, this is a useful, the genes are there, and these genes are so useful that they are displaying that characteristic within the host bacterium also. Means the property of this plasmid is that it carries the it have independent existence, one thing, and with that it carries the information also. And the information not just lying idle there, it can express also. Means all the things that that your normal cellular genome or your nuclear genome is behaving, these plasmid also can show. And what type of things, that ability to survive nominal toxic concentration of antibiotics such as chlorphenicol and ampicillin. So this is a one property, one characteristic that these plasmids bear. If the in cell having these plasmids, then they become drug resistance, like chlorphenicol, ampicillin, etc. So this is by diagram also you can see, and that how they're going to be. And we all have discussed these features while we are talking about the plasmid section of the plasmid, that they are small in size, their numbers are also going to be high, they're not where the bacterial genome, bacterial chromosome, it's a single molecule is there, circular molecule. But in case of plasmid is going to be more than one, or not just more than one, there may be more than one type of the plasmid also may be possible within a cell. Means a cell may have more than one type of the plasmid also. So this is the thing, this is the property that plasmid are going to have, and why they are attractive to us because they can carry the gene of resistance, they can have the replication, independent existence, everything is there that can help. And how these resistance gene can be helpful for you. These resistance gene that we are also calling it a term as a marker, may they help you in the marking the position. So these antibiotic resistant genes which are present on the plasmid, so now we are talking about how we can utilize this property that is present in the in your plasmid. So they can serve you as a marker, and marker for what? Of the selectable markers. Means you can select presence and absence, you can select on the basis of that. So the markers also in this, when you're talking about your vectors or your screening purpose. So markers are of two type. One is a screenable and second is a selectable. So what these screenable and selectable markers are, we are going to talk about it in the later stage. But simply you can say they are select, means you can select. So they are the selectable markers. So on the basis of this antibiotic marker, you can select. If you give the antibiotic, then only those cells are going to survive that having this gene, other that having this plasmid. So simply in way, this is selection. Your other things, those cells we are not having this plasmid, they are going to die. Okay, so to ensure bacterial culture contain a particular plasmid, use of antibiotic resistance as a selective marker for a plasmid is there. So here you can say cell with the plasmid, cell without plasmid. So cell that with the plasmid is going to survive, cell without plasmid that not going to survive. So RP4 is a name of vector that is simply is the plasmid that carry gene for resistance to ampicillin, tetracycline, and the kanamycin. These three different antibiotic genes are present over it. In the previous slide, you can see that this RP4 is having the three resistant genes. So if you grow this cell, the cell which having this plasmid or these three different type of antibiotic, then they are going to survive in the antibiotic culture medium. All these three. So in this way, you can the selection can be do on the double selection, triple selection, mono selections, all that type of things you can do. So only those E. coli that contain the RP4 are able to survive and grow in a medium that contain toxic amount of one or more of these antibiotics. So this is a way, this is selection, this is how why we are calling it as a selective barcode. So normal growth medium, so no antibiotic is there. So in that every cell is going to grow, whether the cell is there with plasmid or without plasmid. But the culture media in which the antibiotic is there, like here the 50 microgram per ml of tetracycline is there, in which no cell that do not have this plasmid will grow, means only those cells are growing which are having this plasmid in them. So this is a way, this is one property that it can carry the gene, and that gene is going to be an expressive also. So all cell can grow, only the vector cells can grow. Then the replication thing. So plasmid, they have the non-integrative one, means the plasmid that now integration and non-integration, two things are there, means whether the gene that you're incorporating within a cell, whether it's going and incorporating within the genome or it is having its independent existence. So thing is that the plasmid have a property that it have its independent existence. It is not going and integrating within the genome. So it has its independence. So whenever you want to take it out, you can take it out, and when you want to insert, you can insert it. Because in case of integrative one, when it got integrated inside the genome, now it's do not have, you can't remove from the cell, or you can't get it again, get back from the cell. So most plasmid possess at least one DNA sequence that can act as a origin of replication. This is a property, the independent existence of the replication, that you all know that DNA replication is going to occur if the origin of replication is there. Otherwise, DNA is not going to replicate. So most of the plasmids have at least one. So in the, whatever you're talking about the plasmid, so there may be more than one. Like in case of your genome, your chromosomal DNA, when you're talking about, so chromosomal DNA have a large number of the origin of replication. So that's why the replication is not just starting at the one end; it is starting at a multiple location within your chromosomes. So, but in case of the plasmid, there is at least one. So the minimal requirement is a one. So if the more than one is there, then also it is going to work equally well. But our requirement is just one, so plasmid is going to have one. This is the second property that we are talking about. So how that means your plasmid is can serve you as a vector. So that means it's able to multiply within cell independently of the main bacterial chromosomes. So it is not dependent on the main bacterial chromosomes. So small plasmid make use host on DNA replicative enzymes in order to copy themselves. So that's why they just keep on copying, keep on doubling within the cells. So some large one carry that code special enzymes specific for the plasmid replication. So that depends upon that whether they are a bit dependent or completely independent. Smaller plasmids that we are going to use for our cloning vectors, so they are going to be small in size, because we have a limitation of replication, limitation of transformation or integrity. So that's why we need small plasmids. But larger plasmids are also there, which are naturally occurring within your cell. So they are totally independent, but we may have a bit dependency for the replicative enzyme that from the your chromosomal DNA. So next is the replication strategy in episome. So what is episome? Episome is going to be membrane bound things. Thing is going to be there, so that plasmids that can integrate, that transfer some of its part to the your nuclear your chromosomal DNA. So that's why they insert themselves into bacterial chromosomes and integrate the plasmid to form episome, and stably maintained through numerous cell division, and then it exit your cells also. So both the type of things are there in one. You are going to have independent one, plus the plasmids are also independent in nature. And if you want to integrate it, if they wish that they should insert, so they are going to integrate. But once they're integrating, it means they are going to replicate with the cell only. So means they are not going to have multiple numbers, so numbers are going to be restrained. So once the cell is going to replicate, they will replicate, and when the cell is not replicating, they are not going to replicate. So this integrative one, the episomal one, replication are not of much importance for us, because we do not want our plasmid to get integrate within the genome, because in that case now it's going to become dependent on the cellular replication. So now next property of the plasmid that is going to have size and the copy number. So size, as I mentioned, the various plasmid are there. There are large number of sizes there. But when we are talking about a recombinant DNA technology, size is important for us because in the cell that we are going to transfer our plasmid, that may not be the natural host of the plasmid. So if the cell is not a natural host, so now one thing you should be get clear that what this host mean. Host mean a cell which is going to carry your plasmid. Okay, because this plasmid, as we mentioned, it's not a necessary component of your cell. It is an additional one. When some additional thing is going to be there, some additional properties are going to become, and not just the additional property, additional burden is also going to be there. So that to manage that additional burden, no one would like to bear that additional burden. So thing is that they would like to remove it whenever it is possible. So, but we want to maintain it. So one thing is there, give at least possible, give burden as much as least possible. So for that you can reduce the size. So the important for the cloning is concerned is size. So less than 10 kb is desirable for cloning vector. So if less than 10 kb is there, then you can load it. So this is the thing. But when you talk about the natural plasmids, they can exceed their size because they are going to present in their natural host. Okay, so plasmid range from about 1 to over 250 kbs in size. Only few useful for the cloning purpose. So they are very large, 2 kb, 50 kb are, so it means we can't use them. So here are the some plasmids that are going to be useful for our cloning, and they are also occurring nature. You can say that the plasmids are PUC8, its size is 2.1. Host organism is going to be E. coli, col E1 6.4, and RP4 54 F fertility factor plasmid, that is, you know, that F plasmid which helps you in the determination of whether the DNA is going to be centimeter or not. Then the tall is also plasmid, it's 111 or so on, and the PTIACH5 is 213. So they are the ectobacterium tumefaciens, they are present. So these are the relatively different plasmids, different sizes are going to be there. So, but when you're talking about the cloning vector, so cloning vector is easy to use when the size is around less than 10 kilo base pair. But larger plasmids are also be there, depending on what type of the experiment you are performing. You are going to choose different plasmids. So these two are going to be important for you because the PUC8 is 6.1, and from 13.1 there you can see the ectobacterium communication is there, but you need to bring it to size as low as possible. So further the thing is the copy. So copy means how many copy of that plasmid are going to be there. So we mentioned there are two types of the replicative forms are there. One is the non-integrative, second is integrative. Once it got integrated, just one copy is going to be there. It means whatever the copy of your cellular genome is there, the same copy number is going to be there for that type of plasmid. But we want a high copy number. High copy number means whatever the number of the plasmid is going to be the same, a number of your genes are going to be there. So in a single cell, if the copy number is going to be high, means the more molecules of your vector is there. So with the more molecular vector is there, simply means more number of your desired sequence, desired gene which you transfer over that vector is going to be there. So number of molecule of an individual plasmid normally found in single. This we call the copy number. Factor control copy number is not well understood. Some plasmids usually that are larger one stringent. However, low copy number of just 1 or 2 per cell. Relaxed plasmid are present in multiple copies, 52 more per cells. Useful cloning vector need to be present in multiple copies. So now this is a property. So now how there we don't know that what factors are going to determine. So this copy number, whether is a host is there or the genome sequence is. So while choosing a vector, we choose a vector which have a multiple copy number. So some sequence are going to be there. We choose those sequence which determine the multiple copy number. Okay, so that's why we are going to, because the large quantity of recombinant DNA can be obtained per cell. If the 50 copy of same vector is going to be there, so per cell 50 times more DNA you can obtain while you're taking it out from there. So this is a copy number, how many copies of same plasmid is there within a cell. So this is a copy number. So other than this copy number, one more property that plasmid is going to have, that conjugation or compatibility. So the conjugation means this is a conjugation that how the plasmid, how the genetic material is being transferred from one cell to another cell. That is the conjugation. I mean, joining this, the fertility. That's the concept of that you have studied in your school also. That two plasmid, they fuse with each other and they transfer genetic material from one cell to the another cell. So that is called the conjugation, or the formation of a conjugation tube, or the fertilization in your bacterial cells. Second is the compatibility, means two plasmid, they can exist together or not. So if two compatible things only can exist, if you do not have compatibility with each other, so no two things are going to be there. Simply you can say in the marriages, so before marriage we search at the groom and bride, they are going to be compatible for each other or not, then only they are going to, marriage is going to happen. So here also thing is there for your vectors also, that they can exist together or not. So plasmid, as mentioned, two types, the conjugative and the non-conjugative. So conjugatives one which form the cubes, the non-conjugative, they are not forming the conjugation. So conjugative plasmids characterize the ability to promote the sexual conjugation between the cells. The process can result in the conjugative plasmid spreading one form to the another form. This is how the genetic material being exchanged. Let's come on to the conjugative one. So conjugation plasmid transfer controlled by the set of genes that called the TRA genes. So TRA genes are one which play a role in the transfer of gene from one cell to the another cell, which are present on the conjugative plasmid but absent from the non-conjugative type. So this TRA gene is going to present if the plasmid is going to conjugative. If you remove the TRA gene, then plasmid become non-conjugative. So non-conjugative plasmid may also, under some circumstances, transfer the conjugative plasmid when both are present in the same cell. So if two plasmids are present in the same cell, one is going to conjugative, another is going to non. In such condition, non-conjugative plasmid also make the transfer of non-conjugative plasmid, because the conjugative plasmid make a transfer tube. And now through this transfer tube, non-conjugative plasmid also can transfer from one cell to the another cell. Then so here kind of single cell. So this we already talked about. So depending on that, compatibility, able to coexist. If they are coexisting, it means they have compatibility. Plasmid is incompatible, then one or another will be rapidly lost. So like thing is, like two plasmid, if you feel that they are not compatible, and if still you have transferred artificial mean, even you have transferred through the artificial mean, but if two plasmid are going to be non-compatible, means they are not going to stay together, then what are going to, through the replication process, they are going to lose one or both of them. So only one will stay. So two, they can't stay together. So this is the one. Different type of plasmid can therefore be assigned different incompatibility groups. So you can assign on the basis of the plasmid, whether they have compatibility with each other or not. So on that basis, compatibility or incompatibility, you have to choose which plasmid you should choose for the cloning. Like sometimes, but we feel that we need the presence of two plasmid. Like one plasmid should be there in a cell, so that it can support the second plasmid. So plasmid from single incompatible group are often related to each other in various ways. The basis of incompatibility is still not well understood. Still scientists are working on what make them to be non-compatible to each other. So this is the thing where we're talking about the compatibility and incompatibility. Transfer the conjugation, that is a simple same thing, how they're going to be transferred. So a conjugation tube is formed. The conjugation tube is called the pilus. So by that, when this plasmid is going to replicate, so this conjugated tube, this plasmid is going to transfer to a recipient cell. So recipient cell, you can see it's not having plasmid earlier, but after conjugation, recipient cell also got the plasmid. So this is a way of transfer of gene. This is a natural way. So how it is going to occur in the normal. So how this is called the horizontal transfer from one cell to the another cell. This gene is going to be transferred.
This is the one distance.
So plasmid classification. So on this basis of different property, different plasmids are being classified. Like fertility factor F plasmid, they are going to have this the transformation that we are talking about. This conjugation that have this gene. There are the fertility plasmid resistance one, those which are having a resistant gene over them. All plasmid, degradative plasmid, and virulence plasmid. Like if the plasmid is going to be there, they cause the virulence. So plasmid F going to carry genes, have no characteristic beyond their ability to promote the conjugation transfer. Example is F plasmid of E. coli. And R plasmid that contain the resistant gene, antibiotic, there's the chromophenical, ampicillin, mercury, clinical micro they are going to utilize. RP4 is a simple example that we have shown that contain the 3 resistant gene over it. And the whole plasmid is going to be, they have the colicin. So colicin have the ability to kill the other bacteria. So colicin is an bacteriocin in nature. So colicin, if a cell is going to secrete the colicin, then it won't allow other bacteria to grow in their proximity. So colicin, you can see it's antibiotic itself. So antibiotic, you know that this discovery of antibiotic, the fungus they secrete the antibiotic. So similarly, bacteria also synthesize antibiotic. So antibiotic synthesized by bacteria are called the bacteriocins, or here the bacteria that is a bacteriocin called the colicin. So it kills the other bacteria. Second, the degradative plasmid, what they do, they allow the host bacterium to metabolize unusual molecules such as toluene or salicylic acid. So with that, they leads to degradation of the cell. Example, toll of pseudomonas putridea. Then the virulence plasmid, they confirm the pathogenicity. This is the one which or the ancient experiment also, like uh, your uh, this pneumonia that cause virulence. And second is also in case of the bacteria, your Agrobacterium, they have the TI plasmids, so they cause the tumor, tumor or crown gall tumor in your plants. So they such types of plasmid, they carry such type of the property they call the virulence plasmid. So both of these are example of virulence plasmid. So it's not just that bacteria are the only those are having the plasmids. So many other organisms also bear the plasmids. That is your E. coli, sorry, yeast. Yeast having a 2 micron circle. So this is the size of its 2 micron. It's the size of that's why we're calling it 2 micron circle. But it's not a plasmid. It's a, or you can say it's a type of eukaryotic plasmid. Yeast is a simple example of it, which carry this 2 micron circle. Uh, so many strains of Saccharomyces cerevisiae. So you can, if you want to, like we know that one property of the plasmid is that it has a replicative one, but the plasmid origin of replication of bacteria is not going to work in case of your eukaryotic cells. So you need a eukaryotic nature of replication. So for that, this 2 micron circle is going to help you very much. So these are simple. You can say that these 2 micron circles are plasmid of your eukaryotes. That's simply yeast or your fungus. Okay, but other than yeast, your higher fungus or higher eukaryotes, they do not have any plasmid like of things, but you can transfer to them. But like even we are not having, we do not harbor any plasmid within them. But if you wish to transfer artificial plasmid within them, and so for that we can utilize this 2 micron circle origin of replication. So this 2 micron based plasmid, you can transfer these plasmid to the cells, and now these two plasmid, they can sustain themselves within the cell, and you can use them for the expression in them. So next type of the thing, the organism that we are referring is your bacteriophage. So what property of bacteriophage make them good for the plasmid, good for them as a vector. So these property that we talk about, these plasmids, so all of these property, as you can say, these 5 types of the plasmids are there, and these 5 types of plasmids have a different protein in them. So many of them we feel that this fertility things and resistant thing, and these property we should combine them so that they should be present on one plasmid, so they can help you. So while we are constructing a vector, we are going to choose, and we are going to choose these property, and we are going to transfer this property to a single plasmid so they can serve you a better job. Okay. Okay, so next thing is bacteriophages. So bacteriophages, or simply called the phases. So as the term bacterio is there, and phases of phase is term we are using for viruses. And so simply they are the viruses of bacteria. So they are the viruses which are infecting bacteria. So there is no, we can say that there is no species which are known which are not infected with the viruses. So viruses are going to be there for every type of the cells. Means viruses are going to be of plants, viruses are of animals, viruses are of fungus, viruses are of bacteria. So these are the viruses which infect them. To them, if the viruses are of bacteriophage, we call them the bacteriophages. So what they are simple in structure, consist of merely DNA, and these bacteriophages. So most of the bacterial viruses are of DNA. Some viruses may be RNA also. And the viruses are there. So this is the property of viruses, that they are have self-replicative one. So this the property, this the replication means they can maintain themselves. So that is going to be helpful. So it means we can use this property of this virus also. And they surrounded by a protective coat that we call the capsid. And so capsid is going to be there. Means you need not to protection. They can sustain themselves. Just when the cycle is going to be there, they will protect themselves within a pot. So it means your DNA is going to be protected within that pot. So different, you can see that this is an example of the structure of your bacteriophage. It has two parts. One is the head, that is called the capsid head, or second is the tail. So tail and head have different role. Head is going to have your DNA, your genetic material within it. So tail have role in the detection and the invasion of the or infection to infect to the next. Host virus, so in which these they are going to stay. So now they can reinfect them. So it means this is second property of the virus that you can utilize. So general pattern infection have three-step process. So first is the virus got attached. So to the tail, it got attaches to the outside of the bacterium. Then it inject DNA chromosome into the cell. So now once it is DNA is got injected, this DNA within the cell may replicate, and when it replicates, produce a multiple copy, and then the replication is over. Then the job is the packaging again. So now it got DNA got packaged within your capsid, and now once this capsid is packaged, then it releases out. So these are the three-step process how this DNA is going to, how this virus is going to replicate. So now this the DNA that's present within your virus is entering inside the cell, and after it exiting also, and not during this process it is going to providing a multiple copy also. So this is again having the features that if you transfer a gene or load a gene over such viruses, so they can carry your gene, and they are entering within the cell. There they are replicating also, and they are, so in this way you can simply say that they can serve you as a vector. So some viruses, so this is the thing, life of the replications, how they're replicating. So a replicative phase of the virus have two different types. So one, it means they replicate quickly, just within a 20 minutes they complete its replication cycle and they come out. But some are there which do not come out, and they stay within them. So those cells, those viruses which replicate quickly and they come out of the cells, that type of the replication we call the lytic cycle. So these all things that I am referring, you will get to study in detail while you are going to study your biology course. So in those biology course, your biology teacher might describe you in detail how this biological events are occurring, what is the process of replication of everything we will talk in the talk in the biology course. But here the important thing is the properties of the virus which make them to utilize as a vector. So they are replicating rapidly. That type of phase is called the lytic phase. Lytic means breaking down of a cell. So every 20 minutes, cell is going to be broken down. So virus will come out, and this virus will infect fresh cell. So fresh cell will also be broken down, and in this way, this step is keep on occurring. So release of new fibers associated with the lysis of a bacterial cell. So characteristic feature of lytic cell infection phase, DNA replication immediately, followed by synthesis of capsid protein, and fast DNA never maintained in a stable condition inside the host. Means inside the host, viruses are not going to stay. As in case of the plasmid, we mentioned that plasmid is going to stay within the cell, it is going to replicate within the cell. But in the lytic phase, viruses are not staying within the cell. So as the lysis is going to as lysis is going to occur. Just a minute. Hello. 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 Okay. So as the lysogeny occurs means your DNA cell going to die and DNA will be out also. So another type is there that called the lysogeny. This is the second type of the replication of the virus that occur. In this case, the virus is retained. The phage is retained within the host. Means virus are not going to replicate. So just a moment. Hello. हाँ 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 क्लास में हूँ तो मैं थोड़ा वेट कर दूँ सवा 11 सवाल कराओ क्लास okay. So so what happened in this case? In this case, your fauces, that's the viruses that we are talking about, they are not going to leave the host. They are not going to replicate so fast, and so that your cell is going to die. So what happened? They're going to retain within the cell for thousands of the cell divisions. So means we are allowing cells to divide. So with the cells, they are also replicating. They are going to integrate it. So as in case of a virus plasmids, we talk about two types of them. One is the integrative one, and second is the replicative one. So or non-integrative one. So they are the integrative ones. They are going and they get inserted within the bacterial genome as a similar manner the episomal insertion that we already mentioned. So like this is the in figure also you can see that virus is going to get inserted, then the lambda DNA, and this lambda DNA is going to circularize, and then the circularized DNA is going to get inserted within the cell. So now it is going to is a part of the bacterial genome, you can say. This is called the lysogen. Okay, so or called the lysogenic. So lysogenic simply can say that they are not distinguishable. So bacterial that carry the prophage is usually physiologically indistinct from the uninfected cells. I mean, you can't differentiate whether the cell is going to have this virus or not. So this is the inserted form of the phage is called prophase. So this prophase is a prophage. This prophase is, you can say, you can match with your DNA, your cell division, mitosis, meiosis, prophase, metaphase. So this prophase is a replicative one. It's staying within them, so you can't differentiate it. Okay, and it is quiescent. Quiescent also means virus is docile. Virus is not giving any harm to the cell. So they are both, so they are symbiotic way, you can say. Both are staying together happily and they are replicating happily. Okay, so this is we can say how it is going to occur. So lambda life cycle is there. So first, you can say two type. One is the lytic phase is there. Second is the cell division, means a lysogenic phase. So the lysogeny is also can be shift to the lytic, but some induction is going to be required. So once you induce induction of the exercise, the host chromosome, new fast particles produced. there. So lysis typically. Now another phase is also be there that we call the M13. So this M13 and this lambda phase is one, and that is have the double-stranded DNA. But M13 phase is a bit different from the lambda phase. But what is a new phase particle continues assembled and released from the cell. So now this is in the first case. What thing is there? First case, lysolytic cycle is a DNA is viruses are replicating, phases are replicating, and when the replication is over, they lyse the cell and work particle are being released. But what is going to happen here? Here, continuous assembly and releasing also. You need not to lyse the cell. New fast particle continuously assembled and released from the cell. No integrated inside the bacterial genome and does not got unisets. So cell lysis never occur. So here the cells are not lysing. So means your culture is not going to die. In previous case, culture will die. But here the cell lysis is not occur. So their continuous culture is can you continuous virus in cells you can maintain. Infected bacterium can continue to grow and divide a bit at a slower rate. So virus and bacteria is growing, but as I mentioned, we said that virus is there. So it have to take care of the virus application also. It need to take care of the virus requirement also. So what it make it retard their growth, but growth is going to be there. So if you see the two growths, so uninfected is going to grow fast and infected is going to grow slow. So you can say the way of infection. So mode of infection is more or less similar of the lambda phase also. Then M13 phases are going to be they're going to keep on replicating, and new phase particles being released. So continuously it is going to occur through the replication process. So many different varieties of bacteriophage lambda and M13 have found in so both of these both of the your vectors based on these viruses you utilize for the cloning. Okay, so gene organized. So main thing is that when you're talking about the cloning, then what different types of genes are going to be there, because these genes are the one whose property you are going to utilize for the cloning. What are the because when we are seeing the lambda phase means we said that DNA is going to replicate. Then the when the number is going to reach a certain level, then the packaging is going to occur. Packaging means your DNA, lambda DNA, to be packaged within the capsid, and then goes for the lysis. So if the DNA do not go and package within the capsid, then it's of no use. So one property that the packaging within the capsid should be there. Then only it is going to be. Then only you can harvest after the lytic phase. So a typical example is a head and tail phase that we have seen. This head is going to be there, tail is going to be there. DNA contain the polyhedral head structure. So this head structure is going to have your DNA. So DNA must be packaged within this head, and because if this package not within the head, then it is not going to reinfect into the second cell to the next for the next cycle. Tail serves as attachment to the phase and bacterial surface, inject the DNA into the host. So the lambda molecule is of 49 kilobase pair in size. So this is the property, the 49 kilobase pair. So anything which is smaller than the size of this 49 kilobase pair can be packaged. So here also the limitation of the size is there. Where we are saying in the case of plasmid, you can stay up to 10 kilobase pair, but here is a 49 kilobase pair. So here you can further increase your DNA load that you can use can be a bit higher also. So it is also intensive study position and identifies all genes in the lambda gene that are known. A feature of the lambda gene map that related terms is clustered genome. So the important thing, this is it's a feature that it's going to have, what different gene it is going to have. All genes coding component capsid are grouped together in the left hand or the third molecule. So what you need like if you want to make it as a vector, so what you need uh, genes for the capsid. So if the capsid genes are not going to be there, then the packaging is not going to occur, because capsid protein are not going to form. You can't remove them. So they are the capsid component. Then coming to the integration of the prophase into the host cell. So if you want to go for the lysogenic cycle, then you need the integration. So these are the integration genes. So these also be required. And the cluster related to the profile important for the controlling the expression of lambda genome it allows genes to be switched on and off group individually. So they are the different genes which you for independent purpose you need. So linear and circular form of DNA. So both the form of DNA can exist. So second feature lambda is cloning vector. The molecule is linear with two free ends. So these are two free ends are there. So while you want to make it a circular or not, these two free ends are there, and they are the cohesive ends are there. So these cohesive ends, they can come to close together and they form a circular form also. So represent a phase head structure. So these are the linear molecule exist in two complementary strand of DNA base pair according to the Watson-Crick pairing, and either end of this molecule a short 12 nuclear stretch, which is a single stranded. So this single stranded is the one we call the cohesive ends or the cos sites. This is a cohesive end, left cohesive end, right cohesive ends, and these left and right cohesive ends they are complementary to each other and they can base pair with one another. So they can come together and pair. So this cohesive ends is also called as a co-site. So why this co-site is going to be important? This co-site is very important for the purpose of the packaging, because any sequence which you found between this co-site is going to be packaged. So that's why this co-site is going to be important. Otherwise, this packaging is going to be hampered. Okay, so I'm stopping now at this moment, and we will continue with this property of your lambda phases, which make them good for the vectors, and what different properties should be there, because while we are going to design our vector, we are going to take some of these property and which are going to determine how to design your vector. Okay, so now before concluding, please let me know any if you feel that any query regarding what we have talked till now. Any question? Any query? I'm audible? And
Yes, sir. No query, sir.
Yes, sir, you're audible. Great.
okay, कोई question, कोई सवाल?
No, sir.
No, sir.
Everything is clear?
Yes, sir.
Because in two classes we discussed the property of your plasmid and the fuzzy. So these properties we are going to use for constructing our vector. And while we talk about specific property, what specific vectors are going to be there, like which host you need a vector. So that is going to have a respective property, respective sequence of your gene. Okay, so please turn on your camera when I call your name for recording attendance. Okay, so Adish,
Present, sir.
Atoiba,
Present, sir.
turn on your camera, all of you. Ayushi,
Present, sir.
Demetrius,
Present, sir.
Devanshi,
Present, sir.
Ishita,
Present, sir.
Janvi,
Present, sir.
Kshitij, Kshitij, Manaswini,
Present, sir.
Namrita,
Present, sir.
Nandini, 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 Nehal,
Present, sir.
Rupal,
Present, sir.
Sahiba,
Present, sir.
Sanjana,
Present, sir.
Shakti,
Present, sir.
Shivani,
Present, sir.
Tanvi,
Present, sir.
Tridev,
Present, sir.
Vivek,
Present, sir.
Vivek, Yukta,
Present, sir.
Yuvraj,
Present, sir.
Nandini, it's your daily issue. Your daily you are facing network problems. So once you got marked absent, then everything will be corrected. Okay, so today you will be marked absent. Okay, so any query if you want to have? So we still have 2-3 minutes.
Yes, student, what is the one order of Baran?
Okay, so if no query, so we can end our session today. So thank you all. Stay safe, stay happy.
One, because one is
Thank you, sir.
Thank you, sir.
Good day.
in this case,